Here is a simulation showing the motion of a projectile. So, it is launched with a velocity v0, as you see here. We are going with the angle which is mentioned here, 45 degrees. See what is the motion of the trajectory. And if you see here the graphs, we have graph of x and y, which is the position along x-axis and the position along y-axis, so two graphs as a function of time. The components of velocity vx, vy, and at that of acceleration ax, ay. We are going to launch the projectile. Let's see the trajectory. We see the trajectory is curvilinear. It is precisely a part of a parabola. So, if you see the graphs, we see the x in terms of time here, the green one, is a straight line. So x is linear as a function of t. So we can say the equation as x equal at plus x0, and here x0 is 0. Okay? A is the slope. So this reminds you from the previous chapter that this along x, it is a URM. Along y, we see it is a curve. Okay, it increasing, then decreasing. And if you see the trajectory, basically the same thing. When it goes up, y increases, as you see here. It reaches a point, which is the vertex, and then it decreases, y decreases until becoming 0. Okay. Now let's see the graph of v. We have vx. Vx is constant. And this is because x is a straight line, and you remember that vx is the derivative of x, whereas for y, vy is not constant, and it is a straight line. If we take the first interval of time from t0 to 1.3 seconds, let's say, we can see that the speed is decreasing. The speed is the value of velocity. We're talking about vy. Therefore, we can say that it is decelerated, and it's uniformly because it's straight line the v. And after the 1.3 seconds, we can say the speed, which is the value of the velocity, the magnitude of velocity, increases, whereas the algebraic value, which is the negative one, this is the one who is decreasing. So for the second interval, it's accelerating. Okay? Now, the velocity, since it is a decreasing line, we can see that its acceleration, as you see here, is negative, and it's around minus 10. The acceleration is negative because we said the line is decreasing. For the first interval, acceleration is negative and the velocity is positive, opposite signs, therefore decelerating. In the second phase, the velocity is negative, and the acceleration is always negative because, as you see here, and the line is decreasing. Therefore, A and V have the same sign, and we can say it is accelerating, which is also mentioned before. Let's now change the angle to see another case. Let's take it, instead of 45, 30 degrees, and we make the launch. We see that the projectile reaches the point, the ground, closer than before. The distance from here to here, we call it, and from the point of launching and the point of impact, we call it the range. We are not going to talk about the graph, they are the same shapes. If now we are going to change the angle, is there another angle for which the projectile has the same range? Let's see. We are going to choose an angle of 60 degrees. Okay? And let us see if we are going to have the same range. So as you see here, we have the same range. So for an angle of 60 degrees, we have the same range as for the angle of 30. This is not a coincidence. We are going to show it analytically later on. And we can already say that the angle for which the range is the maximum is 45 degrees. So two angles for which we have the same range, 45 degrees is the biggest. We are going to show all these during the explanation of the chapter analytically, whether it is to find the equation of the trajectory, the time equations of the components x and y, vx, vy, ax, ay. We will also know how to show why there are two angles that might lead to the same range, and everything that is related to the motion of the projectile. Now, if you have liked the video, of course, you can click on the subscribe button and on the ringtone button so you can be notified for any other videos. We'll meet in different videos.